All right, more good news. Multiplying and dividing fractions you'll probably find a fair bit easier than adding and subtracting them. There are fewer steps, and the probably best part about it is that we don't need to create common denominators for some reason. We can just multiply and divide these things as long as we know the correct steps to do so. So we start out looking at half times a quarter. Multiplication is another way of saying, or is often stated in English as of. So we're taking half of a quarter. We look at a quarter down here. That's what it would look like, and we're looking for half of that much. So multiplication usually makes larger numbers, but with proper fractions, when you multiply, you actually end up with a smaller amount than what you started with. In this case, you can kind of visualize it as I'm only taking a half of the quarter that I had. Okay, so let's get down to the operations to see how this works. And what we'll do is, okay, well, the rules for multiplying fractions are you multiply the tops, and then you also multiply the bottoms, as long as they're not mixed numbers. We'll take a look at those next. So multiplying the tops, 1 times 1, multiplying the bottoms, 2 times 4, that's an eighth. That's it. We don't even have to end up reducing or anything like that in this particular example. All we had to do was multiply tops and bottoms. Here's a skill I'd really like to stress, and you'll see why soon. It's true that we could just multiply the tops of this fraction, multiply the bottoms, we'd end up with 6 over 12, and we could reduce that down to a half. That would be a correct way to do this. I want to try it a different way, because you'll see once we get to more complex looking fractions that contain variables and so on, there's an important system we need to be familiar with. So instead of doing that, what I'm going to do is I'm going to try and reduce the fractions. And the reducing we've learned so far, we look at the top and the bottom, we see, is there any number that can divide equally into both of those? Yeah. Well, not in this case, actually, because 2 over 3 is in its lowest terms, and 3 over 4 is in its lowest terms. Okay, so what am I talking about reducing then? Well, multiplication, we're also allowed to reduce diagonally. This is partly because of mathematical law that tells us that multiplication can be done in any order. We don't need to worry about that right now, as long as you can understand that not only can we cancel top and bottom of fractions, we can also cancel diagonally. So canceling diagonally, we're looking at what can I divide into both 2 and 4? Well, there is a number. I can divide both of those by 2. Okay, so when I do that, 2 divided by 2 would end up equaling 1, and 4 divided by 2 would end up equaling 2. All right, so that part's done. Those were canceled. Divided out is maybe a better term. And then I look at 3 and 3 on the diagonal here, and I know that 3 and 3 can definitely both be divided by the number 3, all right? And we end up with 1. And 3 divided by 3, we end up with 1. So here's our new fraction set down here. Instead of 2/3 times 3/4, we did our hard work early, and now when we multiply this out, multiplying the top, 1 times 1 is 1, 1 times 2 in the bottom is 2. And there we have it. We get the exact same answer that we did doing it the other way. However, we did our reducing before multiplication instead of after. I highly, highly, highly recommend this process, especially when working with larger numbers. It'll make your life much, much easier. All right, so now we'll look at multiplying with mixed numbers. Here, unfortunately, we have to convert them to improper fractions first before we can do the multiplication. And just like we did before, we should reduce these fractions in any way before we multiply them. So let's take a look and see what happens. Well, 2 times 1 is 2, add 1 is 3 over 2. Now that one's converted to an improper. Gets multiplied by 4 times 1 is 4, add 1 is 5 over 4. Okay, now we take a look and see, and 3 over 2 lowest terms, 5 over 4 lowest terms, and when I look at the diagonals 2 and 5, 3 and 4, none of these can be divided by the same number. So our fractions can't be reduced in this case, which is good news. We can just go straight ahead with the multiplication. So multiplying the tops, 3 times 5, 15. Multiplying the bottoms, 2 times 4 is 8. And the very last step, because people don't speak in improper fractions, no one gives you 3/2 of something, they give you 1/2 of it. So because humans speak that way and communicate that way, we'll convert our final answers to mixed numbers. So we're saying 8 goes into 15 just once. We missed it by 7, so there are 7 8s left over. All right, so that's it. The only thing new here is if you start with mixed numbers, you need to convert to improper before you do your multiplication. Next, we look at fraction division. Good news is it's exactly the same as multiplication with just one additional step. You probably memorized this early on working with fractions, where you change the division to a multiplication sign and you take the reciprocal, or you flip or invert the second fraction, and it should always be the second fraction. I learned this as invert and multiply. So that is a correct way to divide fractions, and we will look at that system here. All right, so let's change colors. Yeah. And what that shows us is we've got a quarter, so we're going to invert and multiply, and we end up with a multiplication, which we now know how to deal with, and we also know that we can cancel diagonally or top and bottom, and this time it so happens that 2 and 4 can both be divided by 2, so we end up with 1/2 times actually 1/1. And when we multiply out the tops, we get 1, the bottoms, we get 2. So a quarter divided by 1/2 ends up equaling 1/2. All right, so it doesn't get much more complicated than that, other than what we're about to do, which is divide two mixed numbers. So we just need to convert those to improper fractions before we can do the division. So 3 times 1 is 3, add 2 is 5/3. Actually, I'm not going to do the invert and multiply step yet. I'll do these in 2 separate steps. 2 times 2 is 4, add 1 is 5/2. Okay, so now we've got 5/3 multiplied by 2/5 when we do our invert and multiply steps. Okay, so we're in good shape here. Looks like we can do some canceling. 5 and 5 on the bottom will divide out because we're dividing both of those by 5, and we end up with 1/3 multiplied by 2/1 for a result of 2/3, right, as we multiply the tops and the bottoms. And that's it. That's about all we need to cover, I think, for fraction division, with the exception of one question that I remember having in class. All right, so someone in class asked me about this. 1/2 divided by 1/2 divided by 1/2. Which one do you invert and which one do you change to multiplication? Okay, so this is actually an order of operations question, and with BEDMAS, the overarching rule we looked at is that when operations are of equal power, like they are here, we need to work from left to right. So what I'm going to do is I'm going to do this division first. I'm going to take the result of that and then divide the next piece. Okay, so 1/2 times 2/1, and we're just going to leave this piece there. All right, so what we see here is that 2 and 2 will cancel each other out, divide out, just like we've been talking about before. So that comes down to 1 and 1. So what we end up with is 1/1 divided by 1/2 in our next step. So we took these two numbers, they combined to be that number there. And as you'll see now, there's only a single division question to do because we used order of operations to deal with the first two numbers. Now we'll be able to do the rest. So that could be seen as 1/1 times 2/1, which equals 2/1, and most people would call 2/1 the whole number 2 because 2 divided by 1 is equal to. And there it is.